Welcome to Study Loop.
Hi, everybody. So we need to A, show that the conditions already for, say, process at the top is blank, and B, show that the rate of spin is spin phi on top of the very large compared to the other phi, and C, determine the percentage error. Okay, so this one's going to be a little bit long, which is okay. And so let me just draw what we're looking at. And for this, we have Z, the big phi, we'll put that little phi as dot. We have the big phi, and we also have the W. And we're just going to draw this little thing, and it's not, there we go. There we go. We'll try to make it a little bit nicer. And we have beta is in between here. And from here, we have C sine. Okay? Okay. So we have to express this, the angular velocity of the system. So we have angular velocity expressed as x, I hat, y, this is not, and this is j hat, plus z k hat. And obviously you can tell from this, we don't need the y, there's no y component in the diagram, it's not CC. And we're just going to substitute into our trigonometry into here. So we have phi, which you can see the phi here. Okay. And from the x component, it's going to be sine theta I, and plus the big phi, which is right here. And it's gonna, so we're looking at here, we have the x component is along this line. So we have, let me rewrite the big phi so you guys can actually see it. Big phi plus little phi cosine theta k, and that's for your z component right here. Okay. And now we got to express, and this is, yeah, so now we got to express the momentum about h with O, which is h, O equals I, inertia, xi, plus I, y, y, j, plus I, z, k. Again, we don't need the middle component. And this becomes I, phi, sine, theta, I, plus I, z, k. And we're going to call this equation 2 to help us. And then we express the angular velocity reference frame of OXYZ. So we have phi sine theta I plus phi cosine theta k. And this is going to be 3. And now we can do part A here. Okay. So we're going to do O equals HO XYZ plus delta HO. And this is a cross product, okay? And this becomes, and this cancels out. And now we're just going to do the cross product of sine theta I plus theta cosine phi cosine theta. Sorry, I just keep getting those mixed up. Cross body product of I sine theta I plus I z k. And now we're just gonna scroll down, and this simplifies into I. Oops. I phi sine theta cosine theta minus I z sine theta phi j hat. Okay. And so now we have this equation, which is C sine J. And we're going to substitute this in for this H here. And we have C sine theta J equals I phi sine theta cosine theta minus I z sine theta phi j. Okay? Cancels, cancels, so we have to cancel, cancel, and cancel. Let's scroll down. So from here we have C equals I here, phi cosine theta minus I z phi. Okay. And now we're just going to get the negative sign over. And we have I z minus I theta, phi cosine theta times phi, which is what they wanted you to find. So perfect. And now for B, what we're going to be doing is we're just going to simplify this equation just above. So we're just going to FOIL it out. So we have phi cosine theta big phi minus, we're just going to, sorry, we're going to add this in here. Okay, there we go, sorry. I phi cosine theta phi equals I phi cosine theta plus I capital phi minus I phi cosine theta times phi equals I phi minus I phi cosine theta phi. Let's make sure that you guys can clearly see what that is, and that's the equal sign. Okay. Now, so we know that the little phi is going to be less than the big phi. And here, and because of this, your term by cosine theta is going to be negligible, so we don't really need that. So we have your WC is going to be equivalent to I phi phi. Okay? And now, and that's under the two conditions that they gave us in the problem, by the way. And now we can find, so we got to find the mass, the weight. So here we have 85 divided by 1,000. So we convert that to kilograms times 9.81 meters per second. And we get 0.83385 newtons. We have capital phi, which is its rate of spin. So 2 pi n divided by 60 equals 2 pi times 1,800 divided by 60 equals 188.496 radians per second. Now we have our I, which is mk squared, which we have 85 divided by 1,000 to get to kilograms times 45 millimeters, but we need that into meters, so divided by 1,000 squared, and we get 172.125 times 10 to negative 6 kilograms meter squared. And then we have moment of inertia about the symmetric axis, which is mk squared z equals, we have 85 divided by 1,000 21 millimeters divided by 1,000 to get to meters squared equals 37.485 times 10 to negative 6 kilograms times meters squared. And now we're going to use, so the equation we're actually going to be using is this one. Okay. So now we have our WC, which is going to be 83335 newtons times 0.07. Oops. 375 meters equals 37.485 times 10 to negative 6, 188.496 minus, I'm going to do 172.125 times 10 to negative 6 minus 37.485 times 10 to negative 6. And this is times phi cosine 30. And this whole thing is times phi. And now if we simplify this, we have 0.03127 equals 7065.7726 times 10 to negative 6 minus 116.60 times 10 to negative 6 times 10 to negative 6, phi and phi. So we have 116.60 times 10 to negative 6, phi squared, 70658 times 10 to negative 3, phi, plus 31.269 times 10 to negative 3 equals 0. And now we can do the quadratic formula. So we have negative b plus minus b squared minus 4ac 2a, and then 70658 times 10 to negative 3 plus or minus 70658 times 10 to negative 3 squared, negative 4116.60 times 10 to negative 6. Oops. Times 10 to negative 6. There we go. And 31.269 times 10 to negative 3 divided by 2 times 116.60 times 10 to negative 6. So we're just going to simplify this. And so we have 30.299 plus or minus 25. I'm going to try to write that nicely. 25.492. And so we get a phi that's either 55.791 radians per second or 4.807 radians per second. And now what we need to do is go back to our equation 7. So we're going to go back just to this one right here. And then let's go all the way down. And so we have 0.83385 newtons times 0.03775, and that's meters, equals 37.485 times 10 to negative 6, 188.496 496 radians per second, and we have phi. And our phi is given as 0.03127. Oops. 27 times 7065.772 to 6 times 10 to negative 6 equals 4.425 radians per second. And now we can find the error, which is given as 4.425 minus 4.807, the number that we found above. 4.807 times 100%, and we get negative 7.95%. Okay, thank you guys.